In electricity, the charges that can move, we're usually looking at electrons in metal wires. And electrons are so that it is inconvenient to count them one by one. So in the electricity unit, we often compare, I don't know if you remember this from the video yesterday, but we compare the flow of electrons to the flow of water. Because we can really visualize water flowing. We've seen rivers flowing, we see water flow, like if you've got something slanted, it'll just, towards a drain, it'll flow downward towards the drain. And we might measure the amount of water in buckets of water. So similarly, and this was in the video yesterday as well, we might pretend that we have buckets of electrons, okay? Each bucket of electrons contains, and this is the number we had on the board yesterday, 6.24 times 10 to the 18, which is 6.24 quintillion electrons. That's a whole heap. And if you remember last day, that was a 6, and then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. That many electrons in one bucket. Now, who wants to list out that number every time? Probably not many of you. So instead of saying 6.24 times 10 to the 20 to the 18, we say that we have 1 coulomb of charge. And coulomb is spelt a little funny, and it's because it is named after a person, Monsieur Coulomb, and he was French. So that's why we have the coulomb. So it's the loam, like comb, like the word comb. Okay, coulomb. I should probably actually capitalize it because it is named after a person. So 1 coulomb of charge is equal to, that many electrons is equal to 1 bucket of electrons. So this number is a coulomb. 1 coulomb can be abbreviated 1C. Is that a lowercase c or a capital C? That is a capital C. Okay. A coulomb is a bucket of electrons. I will continue to say that very often. Now, if you remember, charge is the quantity, but the symbol for charge is not C, it is Q. Okay, which is a little inconvenient because normally, velocity was V, time was T, they had normal sort of things, but charge is represented by the letter Q. So that is our symbol for the quantity is Q. And the unit of charge is the coulomb, or buckets of electrons. And the abbreviation for the unit is the letter C. So if you wanted to say the charge is 30 coulombs, you would say Q is equal to 30 C. Just like yesterday, we said T for time is equal to maybe 30 S for seconds. Okay? And if you're like, why the heck is it Q? Q stands for the quantity of the charge. How much charge? Now, do you have to memorize this? No, you don't, because if you look on your purple sheet, okay, and we have this little table here, and it says our quantity, the quantity of charge is symbolized by the letter Q. The unit is the coulomb, and we abbreviate that as C. Okay, so that's all listed for you if you forget. If you're like, I don't remember what to write for charge, you can look it up on this table, right on that front page of your purple sheet. Okay? We're going to do another quantity now. We're going to say, what is current? And again, the video that we watched yesterday showed us what current was. Current is a rate of flow. How fast does something flow? So that's current. So in the video yesterday, we saw a river has water that flows. You might measure the current of a river. That would be how much water flows past a point in a second or in 10 seconds. And one way we could measure it is in buckets of water per second. So the current of the water could be measured in buckets of water per second. But we are doing electricity. We're not looking actually at water. We're not measuring the flow of water. We're going to measure the flow of charge. So instead of measuring buckets of water per second, we're going to measure buckets of electrons per second, or buckets of charge per second. And what is the name of a bucket of electrons? That is a coulomb. What's its abbreviation? C. Okay. So now, once again, we have our quantity, which is current. And sadly, this isn't a C either. It's represented by the symbol I. And we'll talk about why it's an I in a moment. Okay, so that's our symbol for the quantity. The unit usually you'll just hear it said amps, but usually you'll just hear amps, but the full word is ampere, ampere. And that's again named after a Frenchman, Monsieur Ampere, okay? Ampere. And we abbreviate ampere, thank goodness, ampere is abbreviated A. That seems sensible to me, whereas current being I, maybe not as sensible. Okay, so we've got current is I, and amps are A. And the reason that it is I, it stands for the intensity That's where the letter I comes from. It's the intensity of the current. That might help you to remember it, that it's the intensity of the current. But do you have to remember it? No. Why? Because it's on the purple sheet. So we go to the front of the purple sheet and we say, oh, look, there is current. It is symbol, and it even tells you that's the intensity of the current. Its quantity symbol is I. It is measured in amperes or amps, and the symbol is A. Now, if you remember from yesterday, an amp is actually a coulomb per second. Okay, so we will refer back to that as well. Technically, you can give current in units of coulombs per second, but electricity really uses amps most of the time, so I'm going to ask that you try to make sure you change it into amps at the end. Okay? So here is our current I. That is the rate of flow of the electrons, electrical charge, Q, and it's measured in coulombs per second. So in a river, if we are measuring the current in a river, we say, how much water passes a point in a second? Our unit is buckets of water per second. But if we're looking at current in electricity, symbol I, that's how much charge passes a point in a second. So we have buckets of electrons per second, which is coulombs per second. What is a coulomb per second equal to? An amp. A coulomb per second is an amp. So 1 coulomb per second is equal to 1 amp. If we had 7.3 coulombs per second, that would be 7.3 amps. And we watched in the video, you could actually see the coulombs flowing past a point in a second. And I remember making all of you look up at the screen at that point. So hopefully all of you saw those little electrons going past a point. Okay. We usually don't use the word ampere, but it's there so that you know it. Amps are the same as coulombs per second. All right. I stands for the intensity of the current. And now we have a formula that relates current and charge and time. Yes? So current is equal to the charge that passes a point in a given amount of time. So instead of saying current, we can put the letter I. And instead of saying charge, we can put the letter Q. And instead of saying time, we can put the letter T. And if you remember, this formula is called the I quit. I quit. So if you want to memorize it, I quit. You got I equals Q over T. Do you need to memorize it? No, because if you look on your data booklet, here it is right here. So you can have that in front of you anytime you want it. And now, guess what we're going to do? I actually don't know that I like these little 1s and 2s, so maybe we'll not do that. Do you guys want to try and write out the given and the unknown for this question? Do you want to try? Okay, you try. While you try, I'm also going to do it up here. So if you get stuck, you can be like, okay, she's put a box around that thing. What is that? Okay. But remember, what do you get marks for? Everything. So you can check your first 3 steps and say, if I were doing this on a quiz, I would get 1, 2, 3 marks for Q equals 12 coulombs, 1, 2, 3 marks for T equals 4 seconds. Those are my given information. I would get 2 marks for I equals I don't know what, and 1 mark for having the equation. Oh, the wrong way. No. Okay. Do you want to check your second line of work? You should have 12 coulombs over 4 seconds. You should have your answer 3, and then you should have your unit coulombs per second, but better would be if you changed that to 3 amps. And then finally, you would box your final answer. So you would get a mark for changing it to amps, and you would get a mark for the box. Huh? You can do C over S to start with, and then you change it into amps. It's optional as to whether you write it as coulombs per second and then change to amps, or just be like, okay, I know that coulombs per second is amps, and so directly put amps. So you could, if you wanted to, just put amps right here. That would be okay. Does that make sense? One way or the other. Just don't leave it as coulombs per second, because no one in electricity, like in the electrical world, will expect you to write coulombs per second. Okay? And even if we were doing sig figs here, we would have 2 sig figs for 12, 1 sig fig for 4, and so we would have 1 sig fig in our final answer. Okay, these exercises, we're going to let you do those later. What I would like you to do right now is to turn to page 37 and do question 7. And you can get rid of these little 1s and 2s. I think they just make life confusing. So page 37. Oops, wrong way. Check that you get your first 1, 2, 3, 4, 5, 6, 7, 8, 9 marks. So if you got them, put little check marks for yourself. If you forgot something, make sure you put it in so that you know you need it. Yes. Yes. Oh, everyone, when we have a number in science, we hardly ever leave them in fraction form or in mixed fractions or whatever you want to call them. We always put them into decimals. Okay, so you will need a calculator at some point. In other words, today. And if you don't have one today, get one over the weekend so you have one for next week, because on Monday, we're going to have a quiz on this. Okay? With a calculator. Yes. Hi.
The sig figs with this one, would you just add 0?
For this one, actually,
Or
the sig figs are nasty
Yeah.
because the zeros after, like if there's no decimal in the number, they don't count.
yeah,
So you would just have one sig fig, so you would just
Yeah.
have 0.2.
okay.
Yeah, yeah. Check your second line of work. Check your second line of work. I equals Q over T equals, make sure you put in 20 coulombs and 100 seconds, and that you have 0.2. You calculated it correctly. And then it's optional whether you put coulombs per second or whether you go directly to amps, and you need a box. Okay? If you're doing sig figs, the number 20 has no decimal in it. And this is the weird one. If there is no decimal in a number, zeros on the right are not significant. If I had 20 with a dot, if there is a decimal, then yes, significant. No decimal, not significant. Yes, decimal, yes, significant. Those are the weird ones. So technically 20 has only one sig fig. 100 also has only one sig fig, so our answer has only one sig fig. Okay? Okay. Solving the equation. You can go to the washroom. Yes. We're going to move on to a little bit of algebra. Just a teeny tiny bit of algebra. We're going to start on page 38. Page 38. So if you remember in Guess Cubs, we've been skipping over one of the S's, right? We've been skipping over solve. We've always had the thing that we want on the top, all by itself. And I'm going to add in a third one on the left. Okay, so we haven't had to do that. Whatever we're wanting, whatever our unknown is, it's always been on the top, all by itself, and on the left. Okay? Now, it's really hard to write these down so that they're pre-made notes because I have to show every step along the way. So what I'm going to do is I'm actually going to do it over on the side. I have A equals B over C. And if you want yourself a piece of blank paper so you can follow along, please feel free, but you don't have to. The first thing I would suggest to you is that because one of the things we want is we want things on the top, it's hard to see if there's a top if there's only one thing. So I would suggest that perhaps you put over 1, just so you can like see that there's a bottom there, okay? There are 3 ways to do this. You might love one of them. You might love all of them. You can choose whichever method you like. You might have learned one already in math and you're like, I want to do the one that I learned in math. Do that one, that's great. I'll show you my favorite method first, and then I'll show you a couple other ways of doing it. So number 1, we need our thing that we want to solve for, and in this case, we're solving for B. We want that to be on the top. Is B on the top? Yes. Second thing we want is we want B to be by itself. Is it by itself? No. So we need to move anything that is cluttering up the B. Who's cluttering up the B? C. So I'm going to take C, and in order to get rid of it on the right-hand side, I need to move it diagonally across the equals sign. Now, I'll show you what that means. So if I have C on the bottom on the right, it's on the bottom right. It needs to move to the top left. Anything that you're dividing on the right-hand side, you need to multiply on the left-hand side. So it needs to move to the top left. So if it was on the bottom on the right, it needs to move to the top on the left. If it was on the top on the right, it needs to move to the bottom on the left. Okay? So anytime you move one thing across an equal sign, if it was on the bottom, it needs to go to the top. If it was on the top, it needs to go to the bottom. Okay? So what's going to happen now is now I'm going to have C here beside A. I still have over 1. If you don't have to write the over 1, okay? And now I have a B, and B's not over anything, so again, it would just be over 1. So can I get rid of the over 1s now? Yes. So I can say, okay, I don't want those over 1s anymore. I can just say I have B is equal to CA. Is B by itself? Yes. And our third thing is it needs to be on the left. Is B on the left? No. If it's not on the left, all you do, if I write, sorry, I gotta plug in my pen for a second. If I write 3 times 2 is equal to 6, if I put the 6 on the left-hand side, what would I write on the right-hand side? 3 times 2. So I can take an entire equation and what have I done? I can just take the entire thing and flip it, okay? So if it's not on the left, you can flip the entire equation. Horizontally. So we're going to whoop, whoop. Okay? So we'll end up with B is equal to C times A. Is good?
Yes.
Okay. And then you're like, okay, now I've solved the equation, and now I could use that in some guest hub steps. Yes? Now, you might like this way of doing it, but in math, maybe you learned it a different way. So let's take a look at a different way of doing it. How did you learn it in math? Multiply both sides by A? I want B by itself. So I'm going to multiply both sides by C. How do you guys ever learn anything? It's true. Right? Okay, so part of why I get irritated is because it's really hard to talk when there's other people talking. It's distracting. It makes it hard for other people to listen. So it's disrespectful of me and it's disrespectful of the other people. But it's also hugely, and this is the other reason, hugely disrespectful of your own learning. Okay? If you're like, I would like to learn something, I would like to do well in this course, you're never going to be able to do it if you spend all your time talking about other things while the learning is happening. It doesn't work. It's like if you decide, I'm going to go to the swimming pool and learn how to swim, and you just stand in the water and talk. You will never learn how to swim standing in the water and talking. It won't happen. If I throw you out of a boat, you will drown. Got it? Don't drown. Learn how to swim. Okay. This is how we often do it in math class. We're like, we multiply both sides by C. That cancels with that. And so we end up with C times A is equal to B. And with a times sign, you can get rid of a times sign. It would be the same as CA equals B. So we have B on the top. We have it by itself. And now it needs to go on the left. How do you make B go on the left?
Flip it around.
Flip it. B equals C times A. Okay, I want everybody to stand up and show me flip it. Stand up. Put your arms out to the side. Give yourself enough room. And now we are going to, if I need something to move to the left-hand side, if it's backwards, I need to flip it. Okay, everybody, flip it again. Flip it. Flip it again. Okay, thank you. You can sit down now. Yes. One last way of doing this, okay? And once again, I'm going to put a 1 down on the bottom here. Sometimes this works and sometimes it doesn't. Are you guys familiar with cross multiplying? You can cross multiply. So you would have 1 times B is equal to A times C, which is equal to B is equal to A, C. I'd like you to make note that these are actually the same. Does it matter if I have 6 is equal to 2 times 3? Is it okay to write 6 is equal to 3 times 2?
Yeah.
Yes. So it doesn't matter multiplying which way it goes. Okay? Now, because I would like you to have some practice for your quiz, I am going to let you do numbers 1, 2, 3, 4, and 5 on pages 36 to 37. You can make yourself a cheat sheet if you want to, or you can just rely on the purple sheet as a cheat sheet. Okay? Do you want one more question? No? You don't want another, like, what is the current given blah blah blah? No? Okay, that's fine. That's okay. It's all good. It's all good. If you're bored and you want to work ahead and you're like, algebra and me, we are friends. If you and algebra are friends and you don't need like all this training in it, you could do page 42 and 43. So if you want to work ahead, you can do page 42 and 43. Okay?
Hold on, watch this.
Yep.
I literally flipped it wrong. I thought my other way to go now.
Yes.
It's the last one.
Yes.
The last one. The last one. Oh, yeah. Oh, okay. See, I think you guess. The other thing is all I'm trying to do. I'm just chanting the shit. You guys are just oh, but they like away from that. Well, when it's 5 cents. All big persons.
Yes.
This guy, it says I. Yeah. Yes. Hey. Swallow back. No. You start using this back, right?
Say, yes, that's correct. Yes, that's correct.
You're the guy? Yeah, I'm
Correct. You're good.
Good.
Yeah.
Well, this. If I was there, I would want that. Yes. Yes. I bet. I would also this one would also look at. So,